Okay, we're now going to look at more problems, but now even harder. We're going to look at inclined ground. So these are when it's at an angle, right? So in this question here, we're told a package of mass 5 kilograms is released from rest and slides 2 meters down a line of greater slope inclined at 35 degrees. Okay, so we've got this setup here, right? So it's at an angle of 35. We've seen problems like this already. Okay, so we've got this package. So I'm going to say this box here, 5 kilograms. Okay, and I'm told it's released from rest. So initially the speed is 0. Oh no, sorry, it's going to go down the slope. It moves down the slope. So it starts up here at 0 speed. And down the slope, the speed doesn't tell me the speed when it moves down the slope. I'll just call it V. So I've got these two speeds again, right? So let's say the box is up here and then it ends up down here, right? That's the idea. It moves down the slope. Okay. It wants me to work out the potential energy lost, first of all. Potential energy. Okay. So we know that the loss in GPE, the potential energy again is mgh. Okay, so we know the mass is 5, we know that G is 9.8. However, the height, okay, it's going 2 meters down the slope like this. However, that is not the vertical height. This is the height that I'm interested in. How do I work that out? Well, we can look at this triangle here. So if it's 2 meters down the slope, let's say 2 meters there at the angle 35, then we want this vertical height here. Well, we get a right angle triangle and then it's SOHCAHTOA, so we can work out the height using SOHCAHTOA. Well, it's opposite, the height is the opposite side, so the height h is going to be 2 times sine 35. Okay, so if we work that out, that's going to get me 1.15 meters to 2 decimal places. Okay, there we are. So that is my height. That's my vertical height. Okay, so times that by 1.15. So the loss of GPE is going to be 56.21 joules. Okay, to 2 decimal places. Okay. Again, we could make it a negative, but the idea is at the end of this is the loss, right? And it is a loss because we're going down the slope. Okay, we're going downwards. So there we are. Then in part B, then it's asking me to write down the kinetic energy gained. Okay. Now you'll notice the language right down. It's kind of saying you don't need to work anything out. You should already know it straight away, right? So it's asking me to work out the gain in kinetic energy. Now, there is no forces acting on this box here. There's no friction mentioned. There's no driving force. There's no force forwards because it's just moving down due to its weight, due to gravity. So there's no actual forces really acting on it. So it's just conservation of energy. So that means because we're losing GPE, it has to match the gain in the kinetic energy. Okay, and I'll make a reference. It's conservation of energy. Okay, you don't need to write that application, but that's what we're using. Okay, so hopefully we've been there. So it's simply the gain in kinetic energy equals the loss in GPE. Okay, that's conservation of energy. Okay, and so very simply, that also is 56.21 joules. And there we are. That's literally it. Okay. Then in part C, it's asking me to work out the final speed of the package. It's speed V, where it ends up after 2 meters. Okay, so we know the gain in kinetic energy, but we can also work it out by doing the final minus the initial kinetic energy. Well, the final kinetic energy is going to be half mv squared. Well, the mass is 5. So it's going to be 5 times v squared minus the initial, which is half times 5 of, well, it was at rest, right? So at rest, so it had no speed. Yes. So simply, that's just going to be 2.5 v squared. And that has to equal this 56.21 because they're the same, right? And so therefore, v squared, if we divide by 2.5, I get 22.484. So if I square root that, I get v to be 4.74 meters per second. And there we are, 4.74. Cool. So there we are. And so make sure you're confident in how we can work out the potential energy and the kinetic energy. We looked at this last time, but you really need to be confident because they love asking questions. As you'll see in a moment, we're going to look at some exam questions. They love asking about slopes, just to make it as hard as possible. So hopefully you understand the steps there. Okay. Let's have a look at this example. So we're told a particle mass 2 kilograms is projected with speed 8 up the slope of a rough plane, inclined at 45 degrees. So again, we've got the situation. We've got 45 degrees. Okay. Again, we've got this parcel, 2 kilograms. Now it's going up the slope this time. So it starts with speed of 8. Then it ends up before coming to rest, so it ends up with 0 speed. Okay. And it's asking me to calculate the distance it travels, essentially, right? Now, I'm also told the coefficient of friction is 0.4, so mu is 0.4. So, spoiler alert, there's now friction involved. And I know for definite there's friction because it's a rough plane. It's friction. That means it has friction. Okay. So, if it's going to go up the plane, there's a friction going to oppose it like this. Now, there's not a force pulling it forward. Well, there's no reference to it, but also it's projected. So that means it has like an initial kick up the slope. Okay. So there's no actual force applied to it throughout the journey. It's just a literal kick up the slope. So the only force acting on it really is the friction. If that makes sense. Okay. Okay. So that's going to require the work energy principle. So that's going to be the change in kinetic energy plus the change in GPE is going to equal the overall work. Okay. So firstly, the change in kinetic energy, that's quite simple because we know the speeds. We know it starts at A and ends at 0. So the change in kinetic energy, well, the final kinetic energy is 0, so it's going to be 0 take away half of the mass, which is 2, times the initial speed, which is 8 squared. And so that would be 64, minus 64 there. Negative because we're losing kinetic energy. That is important, that negative. Then the change in GPE, that's going to be mgh. So my mass is 2, G is 9.8. And the height. Okay, well, again, I want to work out the distance. So I want to work out this distance here. Okay, how far have I gone up the plane? Okay, I'm going to call that distance x. Okay, x meters. That's what I want to work out. But in order to consider the GPE, I need the height. Okay, this is where there's going to be a bit of algebra involved. Okay, so again, I'm going to construct a little triangle to help me work out the height I want. So again, the angle is 45. The distance travelled up the slope is x, so it'll go up by x. I want my height h. So that means, again, if you use SOHCAHTOA, h, which is the opposite, is going to be x times sine 45. It's going to be in terms of x. So that means sine 45 is root 2 over 2. So h is root 2 over 2 lots of x. Okay, so h is root 2 over 2 lots of x. If I simplify this, it's going to be 49 root 2 over 5 x. And that's going to be positive because we're going up the slope, right? We're going up, so it's positive because we're going up in height. Okay, cool. So then that means if we then look at our work energy formula, I'll box it here. So the overall work is going to be these two changes in energy. So minus 64 at 49 root 2 over 5x. Okay. But of course, the overall work is then split up into the work done by forwards force, take away the work done from backwards force. As I discussed, there's no forwards force. The only force is the friction, which is acting backwards. So actually, if we split this up into work forwards, take away work backwards, that's about, it's going to be minus 64 and 49 root 2 over 5x. Okay, well, there's no forward force, so there's no work in the forward force, right? But the work backwards, well, it's the force F, right? So it's going to be F, so force times distance. So that's going to be force F, and the distance is X, right? That's what we want to work out, the distance. So it's going to be Fx, and that's going to equal minus 64 at 49 root 2 and 5x. Okay, so it's looking quite ugly, but if I want to work out x, I need to find f. Okay, but this is where this coefficient of friction will help me. Okay, so I know that F equals mu r. Now, now there's going to be a reaction force over there. If I get rid of this here, remember there's going to be a weight. Now that's going to be 2g. Now 2g, or 2 times 9.8, that's going to be 19.6. Okay. Now remember, specifically with at an angle, we need to split it up like this. Okay. So it matches the reaction force, and this is going to be 19 point, and so this angle is 45. So this is going to be 19.6 cos 45, and this is going to be 19.6 sine 45. Okay. Now we're going to want to resolve. We're going to want to look at the forces perpendicular, so in this sort of direction. So the force upwards is R. Take away the downwards force, the opposite one, which is 19.6 cos 45. Okay. And there's no acceleration in this direction, so it's just equals 0. That means R is equal to 19.6 cos 45, my reaction, which simplifies to, if I times by cos 45, I get R to be 13.86 newtons there. Okay. Okay, so now I can look to use F equals mu R. I'll do it down here. So mu is 0.4. I know what R is, so that means I can work out friction, which is 0.4 times 13.86. And so that's going to get me 5.54 newtons, and there we are. Okay, now I can use that here. There we are. So that means minus 5.54 lots of x is going to equal minus 64. Add 49 root 2 of 5x. I'm just going to round that as well. We'll get away with that. So 49 root 2 of the 5, because we've already done some rounding anyway. So there we are. We'll be fine with that. 13.86x. That's what that fraction goes to. To two decimal places. Okay, so here we are. So now it's quite a nice looking equation we could solve for x. So that means if we so 19.399x equals 64. So that means x is going to be 3.3 meters to two decimal places. And there we are. That is x. That was the distance between the two sort of points, right? The two parts there. Okay, there we are. So there's a lot there. Okay, that's the thing, right? There's a lot of steps here, but it's sort of pretty much the same thing every time. So once you are comfortable with the steps, hopefully you should be set up quite nicely. So now we've got this question. So here we're told a particle of mass m is projected with speed 5 meters a second down a slope. The plane is inclined at an angle. Again, if I sort of draw the situation, then we've got a surface like this. We've got an angle alpha. Okay. So again, then I've got this sort of object. I've got my what we call particle. The mass is m. So I'm just going to say m. You don't know the number, so it's just m. Okay, kilograms, and it's projected down. So that means, well, it starts with speed 5, and it's going to go down like this. And what we're asked for is the speed when it moves 8 meters down. So when the distance is 8, what is the speed? What's the final speed after 8 meters down the slope? Like this. I'll call it V again, right? V. I'm also told, again, there's going to be a resistance force. Now, again, if it's moving down the slope, the resistance will go up the slope like this. And I'm told the force is a fifth, lots of mg. Okay. So there's a little bit of algebra here with some unknowns. There's an m. Okay, I'm not gonna I'm not gonna convert g to 9.8 right away. I'm gonna leave it there. But hopefully you understand this diagram here. Don't get put off by the algebra, the m's and all that. Okay, hopefully you get the main idea here. It's the same as what we've done previously, or the last few examples. Okay, that's really it. So we're going to use the work energy principle. So once again, the work energy principle, changing kinetic energy plus the change in GPE is going to equal overall work. Okay, so if I work out the change in kinetic energy, well, the final kinetic energy is going to be this V, so it's going to be half mv squared. So half, and the mass is m, so it's mv squared, literally just that. So half mv squared is the final, and the initial energy, the speed is 5, so it's going to be half times m times 5 squared. Okay, and there we are. Then the change in GPE. Okay, that's mgh, so it's going to be mg times h. So again, that's going to be the vertical height here. So again, if I do a little triangle to sort of work that out. So again, I know my distance is 8 meters on the slope. So I want this height h here, the angle's alpha. So again, if we use SOHCAHTOA to work out the vertical height h here, that's going to be 8 sine alpha. Now, I know what sine alpha is. I don't know what alpha is, but I don't need to. I know what sine alpha is. So that's going to be 8 times 3/5. So if I work that out, That's going to be 4.8 meters there, and that's so times by 4.8 here. Okay, now that's going to be negative because we're going down the slope. Okay, so that'd be minus 4.8. Okay, then that's overall work. So it's going to be work forwards, take away work backwards. Okay. Now, obviously, once again, there are no forward forces, right? So there's no force that way here. So the work forwards, because there's no forwards force, there's no work forwards. So it's going to be 0, take away. Now, the work backwards, we do have a resistance force acting backwards to motion. So it's going to be the force, which is a fifth mg. So it's going to be force times distance. So the distance, well, is 8 meters, right? There we are. Then that's just going to equal half mv squared. So there's going to be a bit of algebra here. And then minus a half m times 5 squared. So that's going to be a half times 5 squared. So it's going to be 12.5 m. And then minus 4.8 mg. And so there we are. That's the equation. Now we just simplify this if we can. So we're going to get minus 8/5 mg is going to equal half mv squared minus 12.5 m minus 4.8 mg. Okay. Right, again, don't be put off by the algebra. It's the exact same steps we've been doing so far, but now just a bit of algebra mixed in. Don't be put off. Now now remember, again, there's a lot of letters here, but we want to work out the final speed v. That's what we want to find v in all of this, nothing else. Now, actually, we can simplify this because m's are everywhere. So there's m here, m here, m here, m here, m here. So we can effectively divide everything by m to get rid of it. So that goes to minus 8/5 g is a half v squared minus 12.5 minus 4.8 g. Now let's bring in g's 9.8. Minus 8 over 5 of 9.8 is a half v squared minus 12.5 minus 4.8 lots of 9.8. Now if I just simplify this, I get half v squared. That's going to equal 43.86. I believe. Okay, so therefore v squared times by 2, 87.72. Therefore v, if I root that, I get 9.37 meters per second, and that is my value, 9.37. There we are. Cool.